Welcome to Virtual Labs. Today we will perform flexural strength test on concrete as per IS 516. Flexural test evaluates the tensile strength of concrete indirectly. It tests the ability of unreinforced concrete beam or slab to withstand failure in bending. The flexural test on concrete can be conducted using either third-point load test or two-point load test. We are performing the experiment on a standard plain concrete beam which is subjected to two-point loading. Indian standard determine the size of the concrete specimen as 150 mm width, 150 mm depth, and span of 700 mm. It also states that a size of 100 mm width, 100 mm depth, and span of 500 mm. We are using 100 by 100 by 500 mm plain concrete beam. For sample preparation, determine the proportions of materials including cement, sand, aggregate, fly ash, and water. Mix the materials either by hands or by using suitable mixing machine. Once the concrete mix is prepared and the molds are lubricated, pour the fresh concrete into the molds in 3 layers. Compact each layer by placing the molds on the vibrating table. Once the compaction is done, remove the extra concrete from the molds and smoothen it out using trowel without imposing any extra pressure. Now keep the molds undisturbed for the next 24 hours at a temperature of 27 degrees Celsius. Remove the molds and then moist cure specimen at a temperature of 27 degrees Celsius till the time of testing. Remove the excess moisture from the surface of the specimen. Finally, measure the cross-section of the tested specimen and do the markings as per the specimen size. The bearing surfaces of the supporting and loading rollers shall be wiped clean before testing. The test specimen shall be placed in the machine, correctly centered with the longitudinal axis of the specimen at right angle to the longitudinal axis of the upper and lower rollers. The load shall be applied without shock and shall be increased continuously at a constant rate until no greater load can be sustained. Rate of loading should be 30 Newton per minute for smaller beam and 67 Newton per minute for larger beam size. Fractured specimen shall be examined, and appearance of the beam and type of fracture shall be recorded. Type A failure is when the fracture initiates in the tension surface within the middle third of the span, between the loading points. Type B failure is when the fracture initiates in the tension surface outside of the middle third of the span length by not approximately more than 5% of the span length. In case of type A failure, modulus of rupture FCR is given by the following formula: FCR is equal to PL by BD square. In case of type B failure, modulus of rupture FCR is given by the following formula, where A is the distance between the line of fracture and the nearer support, measured on the center line of the tensile side of the specimen. For 150 mm specimen, A shall be between 200 and 170 mm. For 100 mm specimen, A shall be between 133 and 110 mm. Unsatisfactory failure is when the fracture initiates in the tension surface outside of the middle third of the span length by approximately more than 5% of the span length. When A is not in the given range, the results of test shall be discarded. Once the test is performed, note down the failure loads in the observation sheet and observe the type of failure. Failure in our sample is obtained as type A failure. Modulus of rupture can be calculated with the given formulae as per IS 516. Flexural strength of the specimen is expressed as the modulus of rupture.